Hi friends, welcome to Unit 1, Day 5. This is over quadratic equations. In this set of notes, we're going to be going over different types of quadratics. And let's jump in. If you notice, the first page is an error when I created the notes, so bear with me. We flip over to the next page. Learning objectives. So the main goal in there is to work with quadratic equations. Those are equations that can be written in the form ax squared plus bx plus c equals 0. A, b, and c are real numbers. A can't be 0. If a is 0, then you don't have a quadratic. And we call this a quadratic equation. Quadratic equation. Now this form is called standard form because we have our quadratic term first, then our linear, then our constant. A quadratic equation is called a second order equation. And that has to do with the power or degree of the variable x. So there are several ways to solve a quadratic equation. We're going to be looking at factoring, square roots. We can do this if there's no b term. Square roots. So the b term is 0. We can also do the quadratic formula. And we can complete the square. It's important to know how to do all of these because they all have their advantages given different scenarios. We're going to look at the zero factor or product property first. When you have two factors, if you have like a times b and you have that equal to 0, then you know that either a has to be 0 or b has to be 0. So to solve by using the zero factor property, we need to put it in standard form, factor, and then set each factor equal to 0 and then solve. So for this first one, it says x squared plus 7x equals 60. Right now it's not in standard form. To get it in standard form, I need to subtract 60 on both sides. So we have x squared plus 7x minus 60 equals 0. So now I need to factor this. I'm going to find the factors of 1. Well, that's easy. And then the factors of 60. So the factors of 60, remember we've done this before. 1 and 60, 2 and 30, 3 and 20. Again, my goal here is so that they get that I can combine them to get 7. Let's see, that's going to be 4. 4 and 15. Excuse me. 5 and 12, 6 and 10, and I think that hits 7, 8, 9. Yep. All right, so I know it's going to be 5 and 12 just by looking at that because I can combine them to get 7x. So I'm going to do x plus blank and x minus blank. I know one's plus and one's minus because of our signs. So with x plus blank, let's see, that's going to give me I want the larger of these two to be positive, so x plus 12 and then x minus 5. Set both of these equal to 0 and then solve. So I have x plus 12 equal to 0 and x minus 5 equal to 0. Subtract 12 on both sides. Add 5 on both sides. So my solutions for this are going to be negative 12 and 5. There's a couple ways to write it. That's a list notation right there. If I wanted to write it in set notation, I do the bracket. Sorry, the brace, excuse me, that is brace, not a bracket. That is a brace. Negative 12, comma, 5 brace. That's just another way. Number 2. So this, again, factoring. This one I can factor. This is a difference of squares. So I know that that's going to be x plus 9 and x minus 9. Set both of those equal to 0 and then solve. X plus 9 equals 0. X minus 9 equals 0. So for this one, I'm going to subtract 9 on both sides. Add 9 on both sides. So you get x equals negative 9 and x equals positive 9. So this is going to be negative 9 and 9 for my solutions. You also might see this written as x equals plus or minus 9 like that, where it has like the equal sign and then plus minus because it's the same number. That is a common way to see it as well. Number 3, I need to add 12 on both sides. So I have 2x squared plus 10x plus 12 equals 0. For here, I see that all of these can be factored by 2, so I'm going to do that as well. So if I factor out a 2, I have 2x squared plus 5x plus 6. Now, when you factor out a 2, a lot of students are then confused on what you do with this 2. We keep it. It's part of our original equation, but all it does is change the magnitude of our answers, our solutions. That's all. So our solution sets will still be the same regardless. Like if I factor, in this case, if I factor x squared plus 5x plus 6, it's going to give me x plus 3 and x plus 2. So when I set each of these equal to 0, I'm not setting 2 equal to 0. I'm just setting x plus 3 and x plus 2 equal to 0, and then solving. So subtract 3 on both sides, subtract 2 on both sides, so I get x equals negative 3 and x equals negative 2. So my solution sets for this are negative 3 and negative 2. Notice I'm writing these in order from least to greatest. Please do that. It's a helpful way to make sure that you've listed them all, and just like we read left to right, we read on the number line left to right. For number 4, it's already in standard form, but I can factor out a 2, so I'm going to go ahead and do that. So that gives me a 2x squared minus 5x minus 3, and that's equal to 0. Now I can go ahead and factor this. So let's see, I'm going to get 2x plus, and then x minus, and so I just need to find where I want to put the 3 and the 1. That should work. 2x plus 1, x minus 3, just double checking. Yep, that is in fact the factors of that. Set it equal to 0. Now again, we don't do anything with the 2. We don't set 2 equal to 0. 2 is not equal to 0. We don't set 2 equal to 0 and solve. We just set what's inside the parentheses with a variable equal to 0 and then solve. Subtract 1 on both sides, so that's going to be 2x equals negative 1, divided by 2. So I have x equals negative 1 halves, negative 1 half, excuse me. Add 3 on both sides, you get x equals 3. So my solution set is negative 1 half, comma 3. Join me in the next video as I go over, at that page, but the square root method. Have a great day.